Hey Geometry, let's look at general prisms and cylinders and their cross sections. So first of all, sketch a right rectangular prism. Okay, all that means is a base. I'm going to have a hard time with this, but we'll try. The base, that's awful. Goodness. What I need are the lines to snap to being straight. The base is a rectangle. So a rectangle has right angles, right? And everything is right that connects to it. So these are all right angles. Okay, all of them. Everywhere where everything is connected, it's a right angle. I think that looks about right. Yeah, not bad. Okay, questions. Is a right rectangular prism hollow? Oh, I'm red, sorry. Is it hollow? That means, does it include, oops, the points inside? Okay, what do you think? Okay, let's go through our lesson and see what we learn. Okay, the book did a really good job of stepping through drawing a right rectangular prism, so I wanted to include it here. First of all, we have two parallel planes. So the planes are parallel, they never touch each other. That's what you see in step one. In step two, so we have step one, two parallel planes. In step two, it says let B be a rectangular region in the plane E. At point P of B, consider P prime perpendicular to E. Okay, I think we need to go to step three. Hold on. There we go. So step three, at P on rectangle B, consider P prime perpendicular to E, joining P to point P prime on the plane E prime. The union of all these segments is called a right rectangular prism. So we have all the segments, lots of segments. So a rectangular region is the union of a rectangle and its interior. Okay, in his interior. That helps answer the question just a little bit more, right? It's the interior of it. Okay, now let's talk about a general cylinder. And we have another drawing here. Let E and E prime be the planes that are parallel. Let B be a region in plane E. So it's a region. I don't even know what shape this is. It's pretty funny looking. Let L be a line that intersects E and E prime, but not the region. At each point, P of B, so all these little points in here, consider P to P prime, which is parallel to L, joining P to a point P prime down there. The union of all these segments is called a general cylinder with base B, right? Compare the definitions of right rectangular prism and general cylinder. Are they different? What is the difference? So if we look at those two definitions, they're not very different. In the definition of a right rectangular prism, the region B is a rectangular region. In the definition of a general cylinder, the shape of B is not specified. So this just means for a general cylinder that the region B isn't specified. So we should understand that it can take on a polygonal shape, a curved shape, irregular, etc. Lots of different options for that one. All right, what we would get to now, I've forwarded some graphic organizers for you to try to just get us to organize what's going on with the different shapes that we're going to be talking about. We can draw an example in each category and write down sort of what qualifies the subcategory as a certain title and group of shapes. So we have right general cylinders and general cylinders, and then we can group them into prisms and circular cylinders. So let's see if we can do a little bit of grouping here to help us organize all of the shapes that we've been talking about, and we will continue to talk about. Let's define a few things. First question I would have for you is, what is the term that has the broadest meaning in this graphic organizer? The broadest meaning. What does it imply about the other terms listed? I would say the broadest term is the general cylinder. Since the other terms are smaller sections of the sheet, they are subcategories of a general cylinder. So that's the broadest type. What other subcategories of the general cylinders listed on the sheet? The subcategories would be the right general cylinder, the circular cylinder, and the prism. What are major distinguishing properties between a general cylinder and its subcategories? Major distinguishing, oh, for goodness sakes. Distinguishing properties. Between a general cylinder and its subcategories. Well, we know that a general cylinder with a polygonal base is called a prism. A general cylinder with a circular base is called a cylinder, and a general cylinder with lateral edges perpendicular to the base is a right general cylinder. Oh, I have one more. Let's see if I can squeeze it right here. A general cylinder with lateral edges, not perpendicular to the base, is an oblique. General cylinder. Okay. What do you know about the base of a general cylinder? It can be curved, it can have straight edges, it can have both, it can be irregular, if I can spell irregular. Okay, lots of different options. Okay, let's draw an example of each one on our graphic organizer. Okay, there you see we have general cylinder. The base can have curves and straight edges, and an example. A subcategory, right general cylinder. It's general because it can have curves and edges, but the lateral faces are perpendicular to the base. Right circular cylinder, its base is a circle, but it's parallel and the lateral edges meet at a right angle. Oblique circular cylinder, oblique prism, right triangular prism, oblique triangular prism. These have right edges, these do not. Right edges do not. Okay, it's a really good graphic organizer. I also sent you another graphic organizer. I'm not going to fill it in, but it's a great description. You can take the pictures from the previous graphic organizer, the previous slide, and sketch in a figure here. I'll include one in our answer key if you'd like to check it out. But it gives a general cylinder, just sketch a figure, sketch a cross section, a right general cylinder. Okay, lots of ideas, and there's actually a ton of these pages, so you can page through them slowly, but we've got pictures of these on that other graphic organizer, and I've given you some pretty brief definitions, but here are some better ones, right? These are really good. Here's another graphic organizer. It gave the shape, but you can write in your own description. I can have copies of these for you tomorrow, so you can fill it out as a way to organize your thoughts and help study. But I'll put these in the answer keys of our problem sets. Pretty awesome. I forgot to include this in the slide. Talking about cross sections. So figure 2 is an example of a cross section of a prism where the intersection of a plane with the solid is parallel to the base. So the size of the cross section is exactly the same as the size of the bases because it's parallel. And then here we have a general intersection of a plane with a prism, which is sometimes referred to as a slice. So this one is not necessarily, in fact in here it is absolutely not parallel with the base. Okay, it's different types of cross sections. I would look at a cross section as a slice, like a multi-layer cake where you have a different layer. Those would all be considered cross sections. But that's what I look at as a cross section. We describe a cross section of a general cylinder as the intersection of the general cylinder with a plane parallel to the plane of the base. So that's a cross section. Cross section has to be parallel to the base. So So here's a little exercise in your classwork, and it says sketch the cross-section for the following figures. I went ahead and copied the answer from the book because I'm not that good at drawing with my stylus. But if we sliced this, we would get a circle. If we sliced this, we get a pentagon. You know, here I have a perfect L shape. Here I have an awesome swimming pool. Oops, sorry. But those are all considered cross-sections. And here is your summary. I've got right rectangular prism, which we saw a definition for that in the lesson. Lateral edge and face of a prism, we have those definitions there. And general cylinder. Okay, we'll work through our problem set tomorrow and refine our definitions for all these things, and it's going to be awesome.